So we are dealing with the second problem in the ray optics segment. This is problem number 5.14, and the problem is stating, demonstrate that a light beam reflected from three mutually perpendicular plane mirrors in succession reverses its direction. So if we understand this problem, the problem is technically trying to say that if we have a mirror in the xy plane, a mirror in the yz plane and a mirror in the xz plane, and if an incident ray strikes, then it will be reflected such that after successive reflection it will reverse its direction. So we can prove this simply by drawing a ray diagram. So if we consider the xy plane, so we are just drawing the diagram like this. That is, we have two mirrors installed as y-axis and x-axis. So these are the two mirrors that we have. We can consider mirror M1 as yz plane and mirror M2 as xz plane. So if we consider an incident ray which is incident on the mirror M1, then it will be reflected from the mirror M1 in this direction, and then correspondingly it will be reflected back from mirror M2 in this direction. So the problem is asking us to prove that if this is the first incident ray, then the final reflected ray we have is parallel to the initial incident ray. So if we draw a line of normal at mirror M1 and a line of normal at mirror M2, then we can say that if this angle is theta, then this is also theta. Now as the two plane mirrors are perpendicular to each other, so this angle turns out to be 90 minus theta. This also then turns out to be theta. This is 90 minus theta. Again the reflected ray is 90 minus theta, and this ray is reflected back at theta. So since these two lines are parallel to each other, so we can say that the direction of the incident ray and the final reflected ray has reversed itself after successive reflection.